Hello YouTube, RJ. Well, today is going to be a little bit of a different video. I decided to show how I overcome a little bit of an aggravation in a project I was working on using the tools and techniques that we have available to us. Us geeky people tend to have tools that most people don't. And we need to remember that we can put these to use for a whole lot of good things if we just think about it. So let me tell you about my problem. I have a garage door, actually two of them, 9-foot garage doors, and the bottom sills were wore out. They're way past wore out. They're hard as a rock. And I decided to replace them. So I went online and I found replacement rubber seals, and there's little slotted aluminum tracks on the door that you slide them in. And I couldn't find anything that really matched up exactly. So I got the closest I could. When it came in, it wouldn't fit. As I researched more into it, I found that the doors that I have on my garage are doors from a company no longer in business, and they made their own seals, which were a different size than everybody else. So that ran me into a problem of not being able to get replacement seals that would fit. So a little more research led me to find these. Found a company that sells aluminum rails to replace all in your door that take normal size seals that you can get at any big box store or online. And so they go ahead and sell a seal with it. So I bought this with the seal, and it was for a 10-foot door. Mine are 9, so I was going to have to cut a foot off, no problem. But what I didn't know is they don't really come 10 foot long. They come in 40-inch sections, 3 of them. And that's not a big deal, I guess, until I get into the instructions and I find that because, and I'm going to turn it, hopefully you can see how the notches work here. It's a T slot, allows a T-shaped piece of rubber seal to go in and slide in. You have one on each side of the seal, and the seal, of course, loops over. Well, the instructions makes it very clear that these have to be perfectly aligned from one piece to the other, or the seal won't fit. As you can see, you do not have much spacing in this little slot at the top here. And so if it's off a little bit, it will not, you cannot slide the seal from this track onto the next. So it makes a big deal out of making sure these are perfectly aligned. And I thought, man, that's going to be really difficult up there trying to drill holes and put screws in and get these to line up exactly. So I put my brain to it and I thought about it and I said, how can we make this work better? What we're going to do is we're going to make a tool to align these up for me while I mount them up there. And we're going to put the 3D printer to work making it. So I'm going to jump over to the computer and design up this tool to be printed. But before I do, the first thing I'm going to do is get my micrometer out and measure these pieces. So let me grab it real quick. Okay, so I've got my trusty micrometer here. I'm going to set it on millimeters because my 3D printer likes millimeters more than inches, and they are more precise and easier to work with. And I'm going to get a measurement. First, I'm going to measure the width of the track, which comes out to be just about 9 millimeters. And then I'm going to get the height of that main track, which comes out to be about 4.3 millimeter. And then I'm going to get a measurement of the little T shaft here, which comes out to be about 3 millimeters. Based on those measurements, I'm going to jump on CAD on the computer. I'm going to design some pieces to join these together. And so join me over at the computer and we'll get this done. Okay, we're at the computer. I fired up Rhinoceros 4.0. This is the CAD software I use. And I know everybody's got their own CAD and they're probably saying, no, that's not the right thing to use. Well, I've been doing CAD for a very, very long time, guys. And when I got into doing CAD, there wasn't but a couple options. AutoCAD was one of them, and it was in the, multi-thousands of dollars for a single license. And then you had to continue to pay on and on and on. And Rhinoceros was one that I tried. I tried like 4 of them. It was reasonable. I could afford to buy it. I think I paid about $1,000, and it worked very well. It was easy to learn. I liked it. I did work with AutoCAD some, but Rhinoceros has worked very, very well for me over the years. I love it. So anyway, we're going to create our items to 3D print. So we're in millimeters. We're going to think about what we need to make. We need to make a T-shaped object, and I've scribbled down the dimensions that we want to do. Very, very simple to do in this program. I'm going to make a solid object that is some form of cube or square or rectangle. And it's going to ask me to either click and draw what I want or to type it in. To be precise, I'm going to type it in. So I'm going to do 0, 0, 0. That means X, start at X0, Y0, and Z0, okay? And so I enter. It's going to start my object at the bottom. We're looking down on it. So now it wants to know where the other corner needs to be. Well, we know that we need our piece to be 8.95 millimeters high, and we want to do about 80 millimeters wide. So we're going to go to 80, comma 8.95, comma 0. And if we zoom out here a little, we'll see that we have that. It wants to know how high. Well, we need that bottom thick track to be 3.9 millimeters high. And there's our object. Now, if we want to look at it perspectively, we can go over here and we can shade it, and you can see that what I've created. I've created the bottom of our T. Okay. Now we're going to jump back over to the top. Okay, now we need to make the upright part of our T. So what I'm going to do is a new solid object. I'm going to start at 0, 0, 0 so that I can type my direct measurements in because we're starting from 0. So we know that we need this thing to be 80 millimeters long in X, and we need it to be 2.9 in Y. And then height wide, I'm going to do about 12 millimeters. So now I have this object. We want it centered up, and it's nice because they give me center lines right here. I can literally drag this up, zoom way in to get precision, and line this center up right here. And now we're precisely centered up. So we now need to bring that section up to match where we need it to be. So I'm going to pop up the front view here, and I'm going to slide this tall section up till it's close to the top like this. And if it's hard to make out, look over here at the perspective and you can see what I've done. I just dragged this piece up from the bottom and we've made a T. Now that's two separate two separate objects at the moment. So we're going to join them. So what we're going to do is we're going to say solid object. I need a union. So select the two things I want to union, enter, and they're no longer two objects. If I highlight them, the whole thing is one piece now. If I move it, it all moves. So here's our T. This is what we're going to make. We're going to make 4 of these. I'll probably start by making 2 and make sure they fit good, and then make 2 more if everything's good. So now all we need to do is save these things. So we're going to save as, I've got a folder made up for my track alignment tool, and we're going to call it door track align tool. Okay, going to save that as a Rhino file, and then going to turn immediately around once it saves. I'm saving up to the cloud, so it takes a second. And we're going to save as, and we're going to change the type to stereolithography at STL file because that's what your slicers for your 3D printer use. We're going to stay with the same name. We're going to save it that way. We're going to say that's okay, and that's okay. And it's going to save. And we've just designed this item, and we are ready to slice. So what I'm going to do is I'm going to fire up Ultimaker Cura, and it will of course open up in the wrong screen. I'm sure it did. So let me drag this over where you can see. And we are set up. This setting should all be good. All I need to do is open files, go to my alignment tool and open it. You see her there. I'm going to once again go open recent, open another one, click on it, and I'm going to move it away from it. Okay, now I've got 2 of these T's made up for my 3D printer. Let's slice it. It says it's going to take 1 hour and 21 minutes to do. I've got it on pretty good quality. So we're going to save that G-code into my folder here. We're done. We can close that down. So we now have a file to feed to our 3D printer. At this point, what I'll do is I'll show a time-lapse photography of the 3D printer firing up and printing it. Once I just upload that file straight to the 3D printer and starter, I'm making it out of PETG because that's what I have loaded, and I like PETG quite a bit. So here's the video of it printing. And that's all it takes. And so let's take a look and see how these worked out. Okay, we're back. After I printed those two and tested to make sure they fit correctly, I went ahead and printed two more because there's 3 tracks. I wanted to join all 3 together. And this is what we ended up with. We ended up with those pieces. Let's see how good an image I can get of these. It's a T shape that fits snugly into the track. As you can see, they'll slide. They've got some friction, but they will slide. Take them in and out. And by putting 2 in each end, 2 there and 2 here, what it allows me to do then is to take these 2 tracks, if I can get these on camera, take 2 tracks and actually, with a little bit of work here, put them together. It's hard to do on free holding them like this. So I've just locked them together. Hopefully you can see how that worked. It locked these tracks together, push them together tight. Now, both ends I'll do that so all 3 are together. I'll cut one of them a little bit to get it down to 9 feet. Put them together like this. I've got enough room to get up here where you see it. Here's the joint right here, if you can see it. Do it this way. Now I can take all 3 of them, put them up to the bottom of the door, drill a hole in one end, drill a hole in the other, and then drill the other holes, bolt it all up. And I know that when I'm done, all I have to do is take these and just slide them all the way to the end of the track the same way you do the rubber seal, and take it off, and I'm good to go. I know that when I slide my seal through, I know they're lined up. I know that the seal is going to go straight in from one track to the other, and the problem's going to be solved. So it was pretty simple, real simple idea, real simple to do, and just shows you that, you know, if you run into these things, remember, you have skills, you have tools, you can come up with ways to make your life easier. So thanks for tuning in today. Hope it was a little bit entertaining, and hope to see you in the next video.